Hi, this is Danish. My topic for tutorial is bottleneck distance. So in this tutorial, I will introduce the bottleneck distance between the persistent diagrams. Any persistent diagram, any kth dimension persistent diagram tell us the birth and death of the k cycles. So any point on the persistent diagram, the first coordinate tells us the birth, and the second coordinate tells us the death of the cycle. So let's start with the considering two persistent diagrams, A and B. We have two persistent diagrams, the red one and the blue one. It is not necessary that they have equal number of points. So I am taking here n number of points and m number of points. And for example, A is 1, 3, 2, 7, 5, 6, and 7, 8, and the persistent diagram B consists of the. I will introduce this bottleneck distance in 3 steps. The first step is pairing of the elements of the two diagrams. So the definition, so I start with the definition of the partial match. Between sets. So a partial match or a match between two sets A and B is a bijective map between the subsets of A and B. I denote it by M. For example, here in this diagram, in this figure, I take this M of, let's suppose 1, 3 is equals to 2, 5 here, and M of 2, 7 that is equals to, let's suppose 3, 7, and M of this point, red point 7, 8 is equals to 6, 9. So this is one partial match between the two subsets, the two sets A and B. So in the next step, we define the cost of this partial match. So let's given any partial match, M, the cost of M denoted by C of M defined as follows. So C of M is the maximum of the following 3 things. First is the sup of the infinite distance between AIs and M of AI. Here AI belongs to some subset of A. And the sup of the number half Qi minus Pi for all Pi, Qi points which are unpaired in the match. And the soup of qi prime minus pi prime, where pi prime qi prime are the unpaired points in B. So if we take the soup of the maximum of these three, here I want to tell you this number half qi minus pi is actually the distance of any point, the infinite distance of any point from the closest point in the diagonal. So for any point in the persistent diagram PQ, the closest point on the diagonal is half p plus q, half p plus q. So this half qi minus half qi minus pi is actually the distance of any point PQ to its near distance half p plus q, p plus q. Okay, so the last step is to define the bottleneck distance. The bottleneck distance is just, I'm denoted it by capital D, is just the infimum of all these cost of the matchings. I'm taking the infimum on the all matchings from A to B. For example, in our example, the distance of, so first I will compute the C of the given partial map, which I take. So this is equals to the soup of, sorry, the maximum of three soups. So the first one is the distance between these 2 points. So here the distance between all this, the max between 1 3 and 2 5 is 2 infinite distance, and the distance of 2 7 and 3 7 is 1, and the distance of 7 8 6 9 is equals to also 1. So the soup of all these three distances is 2. And there is one point which is unpaired, and that point is A3. This point is unpaired, which is 5 6. So half of 6 minus 5, that is equals to half. So the maximum of, so this is half of 6 minus 5, which is equals to half. And the maximum of these two numbers is 2. So the cost of the partial match is 2 for this given partial match. Hence, the bottleneck distance will be less or equals to 2 for the given persistent diagram. That's it. If you have any question, you can